Hello, my name is Genya Crossman. I am currently a student in a joint master's program between TU Berlin and TU Delft. I study scientific computing, which is essentially applied mathematics, but my background's actually in quantum computing. So I did my undergraduate as a physicist at the University of Massachusetts Amherst, where I studied just plain general physics, and I didn't know anything about quantum computing and quantum technology, and kind of came into it by chance.
Wolltest du schon immer Physik studieren?
I actually didn't want to go to university originally, but my family talked me into continuing my academic studies because they acknowledge the fact that I'm an incredibly curious person. I love learning. Even if I didn't really love the setup of school, I did well, but I didn't really enjoy the setup of classes and homework and all this. I like learning on the job. But they told me, don't worry, if you just stick with it a little longer, you'll get to learn on the job. And they were totally right, because that's exactly what happened. So I picked physics, which no one expected because I was known for being, head of the drama club. I was a dancer. I was really into English literature class and history class. I would skip my classes sometimes to even go to the art studio. And so I think to all of my teachers and people who knew me, besides my physics teacher and my math teacher, no one expected me to go into physics, but I liked figuring out how the universe worked.
Wie bist du zu einem Job in einer Firma, die Quantencomputer herstellt, gekommen?
I got a text from a friend of mine from university saying, hey, I know you really enjoyed your quantum mechanics course and you were thinking about maybe going to industry and working instead of going to graduate school after graduating. I know a startup in California who works in quantum computing. Are you interested? And I said, I don't know. I don't know anything about it. I'm about to learn actually in the next 5 minutes what that means. Can I call you back in about an hour? And they were completely okay with the fact that I only had a bachelor's and I had no experience in the field directly. So I trained on the job and that was really, really cool.
Kannst du uns erklären, was ein Quantencomputer ist?
To understand a quantum computer, sometimes it's easy to understand what it looks like physically and how it works physically. And there's many, many different ways to actually build quantum hardware. We haven't really, as a society, settled on one, and we may never, but the one that I know very well that I worked on is superconducting qubits. And so what that is you have a processor, it's a little computer chip. You have your circuit, and it's your metal that's etched into a silicon wafer and cut up into a nice little square rectangle. But the fun thing about it is that it's superconducting. And so what that means is the metal that we use on the circuit behaves in a very specific manner when we cool it down to really, really, really cold temperatures that are below the temperature of outer space even. It's about 10 millikelvin. So when we cool it down, the metal behaves in a really particular way where we can actually get it to create a quantum system.
Und wie sehen Quantencomputer aus?
Well, the computer is actually working and it's cold. It just looks like a cylinder suspended by a metal frame with a whole bunch of wires, which can look cool, but actually it's really beautiful when it's off and it's warm, when we say it's warm, and the shielding cylinders come off. And you actually get to see the inside of the computer and the inside of the suspension system. And so it's this beautiful, beautiful system, and it looks very futuristic, where you have all of these wires and coax cables coming down to this point where at the very bottom of the system is where your processor is suspended. And you have all these gorgeous different metals there.
Rechnet ein Quantencomputer mit den gleichen Einheiten wie unsere heutigen Computer?
So in classical computing, we have bits. And in quantum computing, we have quantum bits, or qubits for short, is how we refer to them. And so qubits can also be 0 or 1. Pretty simple and easy. But they also have this kind of neat feature where they can be somewhere in between. And so to understand that, we have this idea in quantum mechanics called superposition, where something can exist between two states at the same time. And it's not that it's halfway between 0 and 1. It's not that it's 0.5. It's that it's actually 0 and 1 at the same time. And so one way to think of this is if you have a visual representation, which is actually how we talk about this technically in our work and research, is there's something called the block sphere, which sounds fancy, but really it's just this idea where you have a sphere and your north and your south poles are your 0 and your 1. And so if you have an arrow that's centered at the middle of the sphere and it can rotate to any point on the surface of the sphere, those represent the different states that the quantum bit or qubit can be in. And so if it's up and down on the poles, the north and south pole, it's at its 0 or its 1 state, just like a classical bit, and it's only 0 or it's only 1. But if it's anywhere else on the surface of the sphere, it's in some type of superposition between those two, where it's actually not yet decided which one it's going to land on.
Wir sind total fasziniert von Quantencomputern. Aber gibt es auch negative Aspekte?
I would say that as a researcher and just as someone who is a part of an emerging technology community and industry, I've started to try and pay a little bit more attention and think a lot more about what it means to be bringing a brand new technology into the world. But we don't really often talk about the negative impacts that a tool can have. And it's not just quantum, right? And any new tool in humanity that we've ever brought into existence, you always have to consider the way it's intended to be used. Initially, the first application, the new ways you'll discover it for it to be used, and then also the ways that it could be abused.
Was ist da ein konkretes Beispiel?
People already talk about one of the potential abuses is Shor's algorithm, which is an algorithm that shows that quantum computers could theoretically, way in the future, don't worry, we're not even close to this, break the way we currently encrypt all our data. But that's okay because we have an entire industry already coming up called quantum cryptography.
Gibt es da noch mehr?
There's also the idea of how much energy does it take for a quantum computer to run. It takes a lot, but if you consider the same problem run on a classical computer, actually a supercomputer, instead of a quantum computer, it's significantly more. So quantum computers actually could be more energy efficient, depending on the application.
Und was könnten wir Gutes mit einem Quantencomputer tun?
With a perfect quantum computer, I would love to see us working in the space of quantum chemistry and understanding how to clean up our water systems and our oceans and our ecosystem from toxins that are insoluble. And then the selfish one is I want a quantum computer to design the next quantum computer. As someone who spent many hours designing processors, and those are very difficult to design on classical systems because, again, quantum computers are much more complex. We say that they're exponential in computing power compared to classical systems. It's very difficult to simulate a large quantum system on a non-quantum computer, which is what I had to do. And it gets tricky. There's a lot of tricks you have to figure out how to play, and it will be so exciting the day I see a quantum computer designing the next processor.
Was willst du uns noch mitgeben?
I would just say get creative and don't stop asking the seemingly basic, obvious questions, because most of the time people who've spent too much time in the space forget that those questions exist. And when you ask them, it usually makes them stop and seriously consider what they're talking about and try and find a better solution. So just stay really curious. And I would just say, I know it sounds really intimidating. It's quantum mechanics, the concepts behind it are kind of really out there and abstract, and it's, the math can be intimidating to people, the engineering can be intimidating to people, but the thing is no one knows all of it. That's the point, is you're supposed to have an entire team or teams of teams working together. So I'm actually part of the first generation of quantum engineers whose career starts with the technology. So we need a lot more of us. So if you want actually just good job security, look into quantum.